All right, what is up, guys? Welcome back to another video. This one was requested by one of our viewers, Offtab Khan, and be sure to send me some video requests down in the comment section below if there's anything that you wanted to see, and if I think that it could benefit a lot of people, then I will feature it on this channel. I thought this was a pretty good introductory question. He's asking about, how does the web work in general? How does, HTTP work? And so, for you more advanced guys, maybe this won't be too interesting, but I know for certain that I'm always learning new things, and even a lot of the topics that in the past I thought like, oh, I don't need to learn anymore on this. I know this. There were little things here and there that I was able to pick up that I was like, either, oh, I forgot about this, or, it's just a good review, right? And so in order to help illustrate this, as you guys can see on the screen, we have TryHackMe. If you haven't checked out TryHackMe, definitely go and check them out. I would say, I mentioned this in another video, but I would say it is the best beginner resource out there when it comes to learning the hacking pen testing skill set. And so let's get right into it. And I don't get any kind of kickback from recommending them. It's just personally, I definitely see the value in this, and I know a lot of you guys do as well. So without further ado, let's get right into this. So yeah, I would highly recommend checking out this room. It's completely free. You don't have to even have a paid membership to TryHackMe in order to do these web fundamentals. But they'll basically, I'm not going to read word for word what's on here. They have a lot of good info here. So I'm just going to kind of use this to illustrate this stuff, right? So basically when we think about websites, we're normally used to interfacing with the web through the lens of a web browser, right? I got Google Chrome open right here. Maybe you use Firefox or anything else. Basically, the web browser is a piece of software that interfaces with the HTTP protocol, or more commonly nowadays, the SSL variant of it, HTTPS, which is pretty much the same as the HTTP protocol. The only difference is it's leveraging SSL to make sure that your session is, just between you and the server, and no one's able to snoop in and read stuff in plain text and modify stuff in plain text, right? And so basically what's happening on the back end is there's just requests and responses, and these eventually take the form of, text. Basically, you can look at any of the requests that you make to a web server, because that's what's happening. When you request a page, right? When I load this page, right? If I refresh this page, what's happening is my web browser is making a request, or my machine, through the lens of my web browser, right, is making a request to the server, and the server is responding back with an HTTP response. And that response contains pretty much everything needed here to load into my browser and render it as we see it here. And that's basically the gist of what you need to know. Now, there's a lot of JavaScript stuff nowadays where you can make modifications to elements on the page, and they can do things dynamically without needing to send the request to the server and it respond back to you with something different. I'm not going to get into that in this video, but at the base level, what you need to know is the internet functions, and as you know, it functions on requests and responses. So, and those requests and responses, those are things that you can view, and you can actually see what kind of data is being passed around. And normally a web server will listen on port 80 for the non-SSL version, but nowadays you more commonly will see it on 443. But it's not limited to those ports. You can have web servers on different ports as well. Some of the other common ones include like 8080, I think 10,000. And different things like that. It's really up to your discretion. But here's what a request looks like. An example of a request here, right? So you have either a get or a post. So if you think in terms of, there's a model called CRUD, right? CRUD HTTP, right? And that is for create, read, update, and delete. Okay? And each one is mapped to a different request, basically. Here is probably a better example, right? So create is normally let's see. Here we go. Good example here, right? Create is normally a put request or a post request. So when you see those type of requests, it's normally you're updating a resource or you're creating a resource, right? I've seen post used a lot for updating resources as well, so that's why I mentioned that here. But normally when you're just reading data, it's a get request. And then I haven't seen this too much, but you may sometimes run into an update request for stuff like that. And also you might see a post request used to delete a resource, but there's also this explicit delete request as well. So these are the verbs here, the HTTP verbs as we call them, and here's what operation it's basically performing. But the two most common you'll see by far is get and post. You can do most things through get and post. You can use these if you want to, and you might come across them eventually. That's why I'm including them for completeness, but mostly get and post, right? So one thing to note is that whenever I request something through a get request, any parameters, any data that I'm passing to the server will be included in the URL, okay? And I guess on the flip side of that, with a post request, any parameters or data that I'm passing to the server will be in the body of the request, not in the URL. So obviously, if I'm logging into a web page, I want to do that as a post request because I don't want my username and password to be in the URL, right? For obvious reasons, that would be a vulnerability. And so when you'll notice when you look at requests that you're logging into stuff, it's almost always going to be a post request. It definitely should always, not even almost always will be a post request, right? And with that being said, once you make a request, you're going to get a response back. And now these responses have different status codes. If everything went well, you'll see a 200, which is a normal response that, everything went well. But you might also see some of these other ones. If I can highlight a few, you might see a 404. I'm sure you're familiar with that, even if you are pretty elementary level experience with this stuff. Everyone's probably gotten a 404 at one point in time. And I can even reproduce that here, right? If I do something like this. Well, they gave a more generic error message, but on some pages you'll see it as a 404. And if I use curl and do it, then you might actually, no, you won't, because they're handling errors differently, but you can produce 404 errors by trying to request a resource that is not found. Okay, so that's what 404 is. You try to go to a page, the server looks for it, it's not there, you get a 404 error. And so that's a common one. Another one is like the 401 and 403. I forget which is which. One is unauthorized, and the other one is you're not authenticated, right? And so, yeah, there's common ones. 500 will be a server error. All of these in the 500 range means it's something that went wrong on their side. Or sometimes if you're doing SQL injection, you can get it to throw a 500 error. But those are the ones you need to know. Oh, yeah, and then 300s are redirects. So these ranges correspond to different things overall, is basically what you need to know. And this is what a response would look like here. I guess I should make note that all this stuff up here, these are called headers, HTTP headers. And down here, this is your data. So yeah, you can see like the host that you're requesting the resource from, your user agent, which is a little header that tells the server what kind of device you're running, and where you came from. That's your referrer. And so there you go. Basically, that's pretty much what you would need to know there. Like I was saying, post requests for logins. If you just want to read some stuff on the page, get requests is normally what that's going to be. And some interesting status codes there. You don't really need to know this one. It's kind of a fun thing. But then, yeah, this one is the unauthenticated. Yeah, so 403 is you're actually not authorized to view the resource. And basically, HTTP is a stateless protocol. So that means that even once you log in, just based off the request alone, the server is not going to know that you already logged in. Now, obviously, this would be a problem because you'd have to log in you would have to provide your credentials for every single web page you tried to visit. Well, obviously, that is not a very efficient system. So that's why we have what are called cookies. And basically, they are, they should be secured values that will specify what resources you are allowed to access once you have established your session, right? Or sometimes you can have cookies just by visiting the site to track that, hey, you haven't logged in. But basically what you need to know is these values will let the server know that, hey, he already logged in and, this is what he has access to or whatever. And so it's a way to track you as a user on the site. Now, obviously, if you're able to get a hold of someone's cookie, you can impersonate them. And this is something called session hijacking, which I'm not going to get into in this video, but know that, if you were thinking, if when I explain this to you, you're thinking, well, if this identifies who you are on the site, what happens if someone gets a hold of it? Well, they can actually impersonate you and hijack your session. And, cookies can sometimes be manipulated if they're not created in a secure enough manner. So that's basically all you need to know there. But yeah, there's also this little CTF challenge that they provide you as well. We can step through that really quickly here. So on the first task, you just make a basic GET request to the server, and almost ready here. We can use curl for all of this. So CTF/get is where that would be located. So 8081 is where this web server is running in this case. So we got to specify that here. And that's how we get our first flag right there. And let's see, the next challenge that it has is a post. So you can use curl to make post requests as well. In this case, the body should be flag please to CTF/post. So I do an up arrow here, I can make it to this endpoint, and then I'm going to use -D for data. If you didn't know that, you could look at the man page for this, man curl, or curl-h for help. You could find that out. And then we'll supply the post data, because remember, you pass the data in the body of the request when it comes to HTTP post requests. So if I make this, and we get our next flag, and then try to get a cookie on this next one. So there's a way where we can make a request to this endpoint here, and there should be a flag where we can actually view our cookies. So we can do this with curl. Honestly, if I needed to look at cookies, I probably wouldn't use curl. I'd probably use like burp suite or something that makes it a little bit easier. But we can also do that as well. I think this is a GET request, right? Yeah, GET request. So we'll just do a couple up arrows here. Was it get_cookie? No underscore. So now we need to check our cookie. There's ways we can do this with with curl. So I'm gonna just search on cookie. So we can actually read the cookie value, and I can't remember, I think it's dash, which one is it? It's one of these. Yeah, so you can actually write the cookies to a file. So that's what we want to do. And then we specify the name. So we'll just call it cookies. So if we cat that, we see here is the cookie, and that's the next flag. And so we can actually set a cookie as well. So basically just setting our cookie with our request. Basically we would, if we were doing this through burp or something, we'd put it in the headers. That's effectively what curl's doing. It's in the header, it's going to have your cookie value when it makes the request to the server. So flag please is the name and the value of the cookie that we want in this case. And so going back to the man page, looking for cookie, we see that, I think it's dash B in this case. And then name equals value. So let's try that. And what endpoint did we need to send this to? Send cookie. So let's make that modification here. Dash B. And then we will say flag please as the name. And then flag please as the value, right? I believe that should be correct. And there you go. We get our final flag there. So that's just basic, really simple challenge here to get you an understanding of how the internet works, and that you don't need a web browser to use the internet. It's just requests and responses. So hopefully this really helped you, Oftab, and whoever else was watching and is new to this stuff, or maybe you learned something if you've been doing this stuff for a while. It was a good review, hopefully. Let me know down in the comments section below. Definitely hit subscribe if you haven't already. Hit the like button to help get this message out there, help some other people that are learning about the internet and venturing beyond the browser, if you will. And if you want to learn more and really get started in your journey to OSCP, maybe that's on your radar, you want to crack into this field, what you need to know for OSCP right over here, and I will see you guys in that video.